Well, this one takes a while. 15. Okay, it says a ship leaves port heading 75 degrees north of east. What do you guys think that means? Well, what's east look like on a map?
To the right.
Right, yeah.
So what do you think 75 degrees north of east would look like?
75 degrees.
Right?
Yeah.
Okay, so it looks kind of like that. So this is the ship's heading. And let's get rid of that. Hit play. It's going 300 miles. Nobody's marking it when you leave, Sam.
Oh wait.
Oh yeah, she had one. She had
Maybe like
two
one or
there.
two.
What's she at, Sam?
Million bajillion.
5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, 105, 110, 115, 120, 125, 130, 135, 140, 145, 150, 155, 156.
Okay. So the question is, how far east did the ship travel? How far north did the ship travel? So how do we figure out how far east it went? Figure out that one. That's our east. How far north did it go? That's that one. Okay, so how do we find out the east here? You always start with the angle, right? Start with the angle. Relative to this angle, east is the what side?
Adjacent.
And we have the, which trig function uses? Cosine of the angle equals adjacent over hypotenuse. How do we solve it when the variable's in the top? Times 3. Everybody's participating.
I got 77 point.
The direction set around to the nearest unit, like the ones place. So what would that be?
77.6.
78.
78 miles east. Okay, and then how are we going to find the north? So relative to 75, this is the opposite, and we have the hypotenuse sine. So same thing, just sine of 75 times 300. Okay, actually that's just the A question. B is challenging. So on B, it says if the ship changes course from this point and travels due east for 300 miles. So this is the ship right here. It went 300 miles that way, and then it says if it goes 300 miles due east, how far is it gone? So basically we need from port. This is port, so we need like how far is it from here to there?
So you have the bottom length, right? 78 plus 300.
Okay, yeah, so she's saying like from here to here, like the east is 78 plus 300. So we'll say 378. And how much is from here to here? Yeah, that was that one, 290. And we're looking for that. How could we do that? Pythagorean theorem. This squared plus this squared, that squared. not hard to do, it's just maybe hard to figure out how to set it up, I guess. So this squared plus this squared equals that squared, so it's 378 squared plus 290 squared, and then the square root of that. Alright, you guys just passed the other class. Well, no, we finished it. You're tied with the other class. And
Just be done for the day, we can get all worked out.
we could do 16 through 18. I think we're going to skip it. I don't think we did anything exactly like that. And we kind of need to cut some fat on this to get through the other class, so we'll skip it.
Okay.
So 19, I guess. Okay. You guys remember this? It's been a while. It's probably like last Monday or something. We did like 6 problems like this. They gave us this little formula. This stands for the arc length, S does, and R stands for the radius, theta stands for the angle. Okay, you guys remember radians and all that stuff? Might be a good page we could turn back to and reference, but this was like 90, and this is 180. This is 270, and this is 360, and that's 450, and it keeps going. In radians, this was 0 radians. How many, let's go over here. How many radians was 180? Pi. And so 90 was half of that, so 1/2 pi, or pi over 2. It's like 1.5, or 3/2, or 3 pi over 2. 2 pi. There was a page that had a good picture for this. I don't know if see if I can find it real quick. 453. Might reference it for some of these later problems, maybe not this one. But basically they're just giving us a couple numbers that we're going to plug in. It says R equals 8, theta equals 5 pi over 6. So just plug that in to find the arc length. So they wrote it like that, 20 pi over 3, and they also wrote the decimal form. I guess they're both okay. They weren't really specific how they wanted it. On 20, they give you the arc length, the S value, and the theta. So how are we going to find the R? Divide. Yeah, so it's not a multiply problem like 19 is a divide. 21, convert to radians. Alright. You guys remember the radians converter? So you want to kind of, remember how pi and 180 are like the same thing? Pi radians and 180 degrees. So you like divide out the degrees and you multiply in the radians, that's the converter. Most of your calculators, I think, will, and you want to just kind of leave pi in the answer, but like Abby, remember, you can just do like 280 over 180 and reduce that and just throw pi in the answer. So that's what did that reduce to? 14/9. That's A. B is 180. You guys should know this one by heart. 180 degrees equals pi. Mallory, every once in a while I think, oh, I'm standing in the way, and then I remember, but not very often. 36. Well, okay. 36 is like 1/10 of 360, so it would be like 1/10 of 2 pi. Anyway, it would be pi over 5. D 335. I don't know if I do that one in my head. I put equals there. Oopsie. But yeah, you just plug that in the calculator every time. Or probably on that page, they probably have a lot of these. Yeah, no, not all of them. Divided by 5 would be 67. 36. Okay, on 22, it's going the other way. They're going from radians to degrees. You could do a converter, like flip this thing upside down and do 180 times 180 over pi, but that's not really how I recommended. You guys remember how I recommended you do it? You can just turn the pi into 180 degrees. So like 22a is just 180 divided by 8 degrees. Okay, 23. Draw the standard position angle with the given measure and state the measure of its reference angle. Been a while since we've done this, reference angle. So, we're supposed to be doing a 500 degree angle. Remember, we start here at 0. Where's 500 going to be? Well, it's more than 360, so it's going to be more than one loop. It's 140 degrees past 360. So where's 140 at? Yeah, this is 180, so it's 40 degrees past, or 40 degrees short of, rather, 180. So the reference angle is basically either how far it is from 180, like this gap, or how far it is from 360. So we kind of just mentioned it. This would be 40 degrees away from 180. So they wanted the picture and they want the reference angle. It's like a snail shell. You guys all here last time the lady spoke at chapel?
Yeah.
Yeah.
Didn't you have back problems last time? I
That's
don't know
yours.
how to explain it.
I don't really remember it, but I remember her talking about it.
Yeah. She said it pretty much, I mean, she added on some stuff, but pretty much pretty similar stuff. It's a lot sharper this time. I'm doing commentary on the video. Yeah?
Singer said last time she said she was in a relationship or something.
She talked about, yeah, when she was, yeah, trans, she was in a relationship with the,
The trans.
yeah, the opposite, yeah. Yes, I don't think she was married last time, or if she was, she didn't mention it.
I don't remember her having a ring on.
You remember that from 2 years ago? I didn't even think to look for
That was
it.
the first thing I noticed when she went out there.
Yeah,
Was that she had a ring on.
That's all I always do.
What?
What? Yeah.
Look to see if they have a ring.
Yeah.
The first thing.
Well, not the
Weird
first
first
thing.
thing.
That's a
Not
weird No, you're not. Okay.
Oh,
No.
you're not doing
I don't-
that.
Literally never.
She's like, well, they're on the maybe list then. Okay.
She has like a list. She's nervous.
Okay, 25. Use the unit circle to state the three basic trig ratios for each.
No.
Sine, cosine, tangent. Let's put it down now. I don't know if I want to use the unit circle.
You have to use the unit circles, Jordan.
Maybe we'll just change it to degrees and then just use our calculator. That'd probably be enough.
Yeah.
Well, they're special triangles. That's why they want to. But okay, let's just do that. 5 pi over 4. What does that come out to? $225, I think we did do a few of these, but I let you guys use your calculator. So anyway, you can just do sine of 225. They wanted to use special triangles, basically. This is what they want done. 225 has a reference angle of 45, and so it's going to be like a 45, 45, 90 triangle. But it's in the third quadrant, so it looks kind of like this. These ones are actually like negative. So, yeah, that's what a 225 kind of looks like. So sine would be opposite over hypotenuse, so it's like negative. So it's like negative square root of 2 over 2. Most of your calculators can do that, though. Except yours. I'm going to point it out every time. Cosine is adjacent over hypotenuse, so it's the same thing. And tangent is opposite over adjacent.
Traffic?
Yeah.
Every day.
Much easy, that's maturity.
Wait.
Oh, it's
I'm
so
happy to
easy.
scroll up
I
that
know.
much.
I was so happy when I got it.
Jordan's pretty easy too.
Mine's kind of hard.
Courage.
What's yours, Jordan?
Acceptance. Very easy. I got freedom. Okay.
That's easy. I got innocence.
That seems hard.
I feel like I wrote freedom in my book a lot.
What's
Mr.
yours?
Smith talked about it a lot. Maturity. I wrote cruelty.
Really?
Yeah.
Okay,
I feel like I just have that note all the time when I'm thinking back to it. Interesting.
on 27, we might stop. This might be a good stopping place at this section. You can just use your calculator. How do we do, like 29 secant of 270 though? Because secant's not a button on the calculator. Remember?
Cosine.
1 over cosine.
How does it feel true? It's a guess. I don't know how to sine and cosine.
Where'd you get the secret?
So, is this?
That's 29.
You want us to just do that?
Yeah, just go ahead. You can use your calculator, it's fine. They wanted you to use special triangles, but I don't really care that much. I would like you to know special triangles, but
Do they just?
what?
I was confused. I thought you had to do like the thing where you drew a circle around them.
They did want you to do it. It's kind of like what I was talking about up here. Like number 27 is 150, which is like right there, which is like 30 degrees short of 180. So they wanted you to use this 30, 60, 90 thing. And do like sine is opposite over hypotenuse. But the calculator can do it. So it's okay.